I'm resuming my Advent of Code streaming challenge using Lamdu. I took a small hiatus from it, doing some holidays, birthday, weekend, vacationing. Yeah, so I'm tweaking up the format. Now I looked at the problem beforehand. Also, the problems are becoming difficult, so I won't necessarily want to tire you with the full two-part ideal efficient solution. Even maybe a correct solution for the first part. This does look like a fun problem, though. I'm sure there's like an efficient solution here. I don't know what it is. I'm going to implement the naive one using Lamdu's mutable functionality. So what we have here is we're giving a list of numbers like this, and each one moves according to its value in the list. Ahead, we can move it ahead. So first we move one, then we move two steps forward, and then the next one in the original order was -3. We move that 3 steps backward. And then we have a final list, and we need to sample a few positions in the list and add them together. This is the question. Now there has to be some intelligent solution to this, and I will keep it as a riddle to think about, but I will demonstrate solving it naively. So let's start with copying the input example. Okay, and we'll split 4 lines, and we will map with parse of a number, right? And so we have a list of numbers. And also let's call it Advent 20 example input. All right. So let me also make myself smaller here. Feel free to ask questions in the chat if you're viewing live, or leave comments after the fact. So this, I will call it the parsed input. And what we would want to do is to go over it in the order we have it and mutate it, but then we don't want to process one again. So we'll leave a flag. So let's do it, have a record. Number equals num, and done equals false. And let's make, okay, so we're going to do this in mutable world. So we're going to run a mutable process. This is the Lamdu equivalent of Haskell's stmonad. And we don't have the do syntax trigger yet. It's going to look better in the future. So I want to make an array. Do we have something that makes an array from a list? Possibly not. We should have, but I'll just append this list. Let's put it here and do a for, and okay, we could do the mapping here. So let's not map. Let's just do the parse thing, and let's add to the array. Yeah, we can call it state, I suppose. The record of num being num and done being false. And then let's make a loop starting from position 0. Let's move myself. So let's make this loop where we read the array in this position. We read from state in this position. And yeah, actually, let's do, if we reach the end of the array already, then we're done. So let's make this or actually, let's just iterate over all of the positions in the array. So first of all, let's figure out what the length of the array is, though. So length of state, yeah, it's 7 in this case. We call it len. Right. Why do we have 2 completions for len? Oh no, sometime this len. Okay, the Lamdu standard library has 2 words for. Oh, there's a word called len. That's not good. I don't know, maybe I made it by mistake at some time. What happened? Okay, this is the right len, and actually let's use the word n for the size, whatever. And we will iterate. Okay, we'll iterate over all of the indices 0 to n. And we'll do for loop. And it could be the case that in a certain position, like position 0, we move it forward, and then we have something else there we want to process. So I'm going to do a loop here. And yeah, it has no accumulator in the loop. And it goes like this. We read, let's call this num index. And we'll read the array at the index. Okay. If it's done, then we don't need to resume the loop. So yeah, the loop is finished. By the way, happy Hanukkah, holidays, Christmas. Here's my sufgania. It's good. So I'm going to treat a negative index as a cyclic move forward instead. So let's make this thing move. If num is bigger or equal to 0, then it's num. Otherwise, it's going to be n plus num. Or actually, I don't know if they're going to give like numbers like million. So perhaps the best thing to do is just use the modulo. So yeah, num modulo n. So now I'm going to loop again for everything from let's do this. Let's sorry. We're going to shift everything one step backwards. So let's read the last item first. Index plus move, which is the same as plus num modulo n. This is going to be, oh sorry, this needs to be in the right side of the read array, and we're reading from state. Yeah, so the place we're moving to is this 2, right? And now let's iterate over the indices from move dot dot. We'll do it backwards, dot dot with a step. Move -1. And we'll fold over these. Where the initial value is this record we have here. We will read the hoping as Lamdu is currently compiling to JavaScript, I hope that our modulo operator is proper like in Python, not faulty like the C and C++ modulo operator for negative numbers. Index plus item. So we read what is there. Which actually isn't needed for the last one. So maybe we should not do it all the way to the last one. Okay. We read what was there. We write the previous thing to it. So actually, let's call this thing position. And you write to the same position the previous value, the accumulator in this fold. And then we continue to the next step with the value we just read. At the end, we can give this name at the end we're at the same index we read, so we write to it. Okay, so we've done the shifting the items. We just need to write the last item in the loop. Wait, is this after the loop? Okay, I'm going to turn off the annotations and maybe decrease the font size so I see what's going on. So this is the lambda for this loop. We want to do one more thing in this loop, which is writing what just happened? Sorry. Oh, I didn't show the keys I'm pressing. Sorry, I forgot keycaster. Okay. Let's see. Okay, let's put the keys here. Okay, so now let's, okay. Inside this lambda, I want to add another step. So I marked it using shift left. Yeah, if I press semicolon, I add another step, which is to write at the destination. Actually, not if it's done already. It's only in this else clause if it's not done. Right, so you mark this, semicolon, okay, actually, it's simpler than that. Instead of reading from it here, yeah, we'll start with putting there num1 and done equals true. And we don't need to read there. That's what's going on in the loop. Okay. So and move is only used, yeah, so let's place it here. Okay. So what we do, go over all of the indices from where we need to put the new item to 1, basically. We count down. We read what's there, we write the accumulator, and we started with the item that we need to move there. And we continue with what we just read, which will be written to the next position, and at the end it will be written to the index we are processing. So this should be the naive thing. Yeah, so now we just need to take the indices over here, 1,000, 2,000, 3,000. So let's do it like this. From 1,000 to 4,000, steps of 1,000. We will, yeah, let's fold over these. Let's start the sum with 0, and we'll just return the value we finished in. This will be the result. So we read the state in the item position. And we continue with accumulator plus num. No, not at item, sorry, at item modulo n. Yeah. So this pretty much should be it. Let's make evaluations. Is the result -4 at the end? No. So it must be like off by one thing. Maybe they're calling the first one 1 and not 0. It's the result -2. Neither. So let's see. Actually, it might be nice at this point to see, well, it might be nice at any point, actually, just for debugging purposes. Lamdu has pretty good debug facilities for the pure part, but in this case, it's not really the case. We want to see what, just for debugging purposes, what the array was. So I'll make like this. So the fourth thing, it's do I have something to freeze a mutable array? Yeah. So, yeah, so let's do this. Freeze state. And just gonna look at it and continue. And yeah, so let's do evaluation again. So I want to see the array here. Okay, So after the first iteration, we have 2, 1, 2, 1, minus 3, 3, minus 2, and it's only showing me the first 5 rows because, yeah, this is, but only one has the done flag. And now, sorry, I want to see the next time this loop runs. So it goes to index 1, great. Now, after, okay, no, not goes to index 1, sorry. So this loop, it's not done. Oh, I forgot continuing. That's the thing. We're not returning, we're continuing the loop at the same place. Yeah. Okay. Okay, then it's 1 minus 3, 2, 3. Okay, then it goes there, it's done. Okay, so yeah, this looks pretty nice. So we don't need the freeze part, so let's remove it. Sorry, okay, what I want is just the continuation. I mark it and I press Command Delete to delete the parent. Now let's do what we did again, sorry. Okay, actually let's freeze the array just to look at it at the end to see that we have the right result. Okay, so the last one was, we don't have the correct final result, which is interesting. All the stuff are done. So what are the edge cases here? Maybe we're not handling the negative ones well. So at the first index we had 1, and then we had 2, and then after moving 2, 1 was done, it's true. Then we moved to the second index, and we read minus 3. And then where did we move minus 3? So the modulo is 4, that's correct. So minus 3 should move 4 steps forward. 1, 2, 3, 4. Okay, so it's actually 3 steps forward. So I guess this just shows it should be, I guess, modulo. Wait, yeah, I guess modulo n minus 1 apparently. I don't know. Yeah, so it should move 3 steps forward. Now let's see what the final one is. Does it have the right result? No. Okay. But it's close. Might be our handling of 0. Okay, so we read the minus 3, and then we resume the loop after moving it, and in its position it's 2, which is done. So we move to the second place where we have 3. which is not done. So we move that 3 steps forward. Yeah. Okay. And after that, in its position we have -2, which is not done. So we move it. We move it 2 steps backward, which are also 1, 2, 3, 4 steps forward. Oh, sorry. 1, 2, 3, 4 steps forward. Okay. Then we read -3, so far looks good. Then this position. So before we finish with -3, it was done. We move on to index 3. This 0 is not done. Okay, what happens next? It stays 0. Okay, let's look at the 0. The loop never even happens once. We read it and we write to it, just make it done. And then the next time we read it, we're done. That's good. Then index 4. We read 3, which is 3 that we pushed. It's done. Okay. Then on index 5, read 4 that we need to process. Okay, so that I'll do the let's make an array of the arrays just for seeing when it's different after each step. So with the do notation, we would, this added it in a weird place actually. So with the do notation, the experience would be nicer, but I want to add an action before all of this, which is, and this actually adds an action after all this, which isn't what I wanted. Let's undo. Let's extract this. Let's go here. No. Yeah. The mutable part of Lamdu isn't great yet. Okay, now let's look at the freeze state at each step here. So, what is the key to go across scopes, navigation, debug now. Yeah, we have the help should be searchable. Value scope next, alt down. So let's do this. Alt down, next scope. Okay. We have 1, -3, 2, 3. Okay. Next scope. Okay, it was done. Then 1, 2, 3, -2. Okay, good. So I guess we want to see, let's see, just the content of the arrays would be easier. So let's so I want yeah, okay, I'll do this. Here, I'll just add a let item here. Command L, Alt L, sorry. I'll do from array, from the freezed array. And turn off the annotations. Map. I don't care about the done, I just want to see the number. And then we'll do to array. Okay. Now let's see the evaluation results. So 2, 1, -3, 3, -2, 0, 4. Good. Next. 1, -3, 2, 3, -3. Great. Next. Next was in the done case. Okay. 1, 2, 3, -2, 3, 0, 4. Good. Next. Okay. Next. 1, 2, -2, 3. Okay, this is good. Next. 1, 2, -3, 0, 3, 4, -2. Good. Next. We're done at this stage. But so we're done at the stage of the 1, 2, -3. Okay. So what may have happened is we may have skipped over items we need to process by pushing them backwards. Is that something we could do? I don't know. I don't think that can happen. Okay. So, oh, I guess the only one left to do is the 0. Somehow skipped processing the 4. So we are in position 2. We're in position 2 of the array where the -3 is. Oh, wait, is this okay? Let's find the very last scope of this. Okay, when it was index 6, it was done. Index 5. We read the 4, and the 4 was not done. Okay, so we did push the 4. Oh, sorry. Okay. Push the 4 moves between -3 and 0. So okay, so the way we move the 4 is different than what they have here. It's between the same stuff, but the one is at the end instead of the beginning. So how did that happen? Okay, so there's different behavior. There's different behavior whether we so the way I did it, the 4 minus, like, takes the step, the position of somewhere, and that thing moves backwards. But the way they did it is different. So we don't always shift stuff backwards, sometimes we shift them forwards. I'm not clear on what is the interpretation. So if 4 was actually moving forward, it would -2 would take its place, and then 1 would take its place. So yeah, the instructions are not really clear to me. Okay, so yeah, it looks like it's a funny condition, I guess. So let's call this the shift. In all the cases we had until the 4, then number plus shift didn't go over n. Yeah. So let's do if number not number, index plus shift is smaller than n, then we do the action. And the only case where this didn't happen was in the case of 4, so we can check it out. If we do evaluation now, and we go for the next iteration, okay, so in the case of shift being 4, we got to this place. It looks like the behavior here is different. Instead of doing shift left, we're just going to do shift right. So yeah, funny behavior. So similar loop, I guess. Four moves. use the same list. I'll fold over it. Now the shift left is a different. It's a different shift. So a shift right of 4 becomes a shift left of 2. So let's do. We'll do fold, yeah, and we'll do dot dot with the same step of -1 to 0 from n -1 minus shift. So I'm going to do a shift left of 2. We're going to do something similar, but we have a minus item. So index minus item modulo n. We also call it pos. And let's turn off the evaluation so things don't move around. So, okay, I'll write it and then we can think whether we can do code deduplication. So we use the same initial value. And we also have the same tail. Just call it tail. So enjoy the this clean syntax sugar. So the same thing happens here. We finish the rotation. So now we handle this case. So now if we enable the evaluation, check out this at the end. One, two, minus 3. 1, 2, minus 3, 4. Yeah. So okay, we have the right thing at the end. So let's do this. Yeah. And we do have this final array. So let's just do sum of, we want to return it from the mutable computation. So I'll turn off the evaluation. return sum of 1000 up to 4000 steps up 1000 map. So there might be a -1 involved here, or +1. Oh no. Oh, they're saying after the value 0. So we need to find out where the 0 is. All right, so all right. So we should be adding 4 minus 3 and 2. 4 minus 3 and 2. Yeah. So it looks like we have the result here. Let's make it into a function that gets the input. Okay. Let's see what my puzzle input is. It's this thing. Okay, let's see if my code is quick enough. So I'm sure there's a intelligent algorithm to do this, or an n square complexity, doing all of these array shifts. And in a quick enough compiled language like Lamdu will be in the future, it should be done in a second. But right now we're compiling to JavaScript. So let's see if it's over by the time we finish this Afghania. One way to make it more efficient would have been to use a data structure mm, like binary search tree for holding the sequence, also counting for, okay, so it's finished. Let's see if the result is 7004. Yes. Nice. So part 2. Part 2, I guess I'll do after the fact. So if we had a data structure like balanced binary tree containing all of the elements, and also retaining the number of all elements in each subtree, then I suppose doing these shifts on that data structure could have been efficient. Now, we don't currently have such a data structure in the Lamdu standard library. Yeah, and it would be quite involved to implement it. So this will be it for today. Happy holidays.